Hello everyone, thank you for joining this webinar. My name is Violet Seah from Enterprise DB APJ Marketing. I will be your host today for our webinar on Discover What's New in Postgres and Advanced Server 12. I'm joined by Bruce Momjian, co-founder of the PostgreSQL Global Development Group, and Marc Linster, EDB's SVP of Product Development. We are very happy that you can join us today. And before we get started, I want to go through a few housekeeping items. This presentation is being recorded. We will be sharing the recording along with the slides after the broadcast. The lines are currently muted, but if you have a question, please feel free to submit it in the question panel. Today's session is scheduled for approximately 1 hour, but the presentation will last about 45 minutes, and we will have some time for Q&A. If we do not have time to address all questions, we will follow up afterwards with any attendees whose question was not answered. So without further ado, let me hand over the floor to Marc and Bruce. Over to you, Marc.
All right. Thank you, Violet. Thank you. So as Violet said, over the next about 40-45 minutes, Bruce and I will take you through what's new in Postgres 12. We'll talk a little bit about PostgreSQL 12, so the open source version, and we'll talk about Advanced Server 12, the EDB enhanced version of Postgres. So from an agenda perspective, what I'll do is I'll take us briefly through who is EDB, and then we'll turn into PostgreSQL 12, which will be the lion's share of this presentation. And then, as I said, briefly, we'll touch on Postgres Advanced Server. And then, as Violet said, there will be questions for time for Q&A. The discussion of who is EDB will just take a few minutes, so bear with me, and then we'll dig into Postgres 12. So first, who is EDB? EDB has been working on Postgres for now 15 years. We've been active contributors to the PostgreSQL project for 13 years. We're active on the open source side of the house and on the commercial side, where we've been recognized by companies such as Gartner or Forrester. Today, we have over 4,000 customers, 300 employees, and with offices worldwide, not just in the U.S., but also in APJ and in Europe. So let's talk a little bit about the recognition that we got from Gartner for the work that has been done in Postgres, of which we are a part. So Postgres has been listed, or Enterprise DB Postgres has been shown in the Gartner Magic Quadrant since Gartner restarted that work in 2013. So in every one of those editions, EDB Postgres has been recognized as being capable to support enterprise needs, both in completeness of vision and in the ability to execute. There's one specific thing that I want to bring to your attention when you look at this depiction of the Gartner Magic Quadrant. Postgres, Enterprise DB Postgres, is the only open source relational database that is remaining in the Gartner Magic Quadrant. And that's really a recognition of how far Postgres has come in the ability to support enterprise workloads and to work with partners such as Enterprise DB to make sure that companies worldwide can be supported in the deployment of Postgres in their enterprise. I mentioned that we have over 4,000 customers. They're not just in North America, but we are very, very active in Asia Pacific with customers such as Korea Telecom, Samsung, Alibaba, Hyundai, SoftBank, etc. So we are very well represented within the Fortune 500 in the US and the global Forbes Global 2000 across the world. Bruce and I work with many of these customers, and I can tell you that they're not using Postgres for something small. Many of these customers use Postgres for mission-critical applications in support of major parts of their enterprise.
Mark, actually, looking at that chart, is
Yes.
Costco the steel manufacturer in Korea?
I believe that's who they are, yes.
Yeah, I was there once. Someday I want to go see the steel mills. I'd love to see that someday. You ever seen one?
Yeah.
Must be really cool to see.
A steel mill, yes. I come from Luxembourg in Europe, and we were big in steel industry for many years. So
cool.
absolutely,
that is cool.
Yeah.
Yeah, so I've been to a lot of these logos, and it's a lot of fun. I mean, going to MasterCard and some of these other ones, it's a lot of fun to kind of go and talk and see what they're doing. And I don't know, it's exciting to sort of see the spread. I mean, look, we got like 20% of the Fortune 500, I think 15% of the Fortune 2000. So, we got a lot of growth to go, but a lot of these logos are familiar to me, and I've enjoyed visiting a lot of these customers.
Yeah, and they do very interesting things. I mean, there's IoT applications in there. KT is using Postgres for many applications that drive significant amounts of data. So there's lots of reference and case studies. So again, for our audience, if you're interested in the case studies, let Violet know. Let us know as part of your questions, and we'll make sure that you get the corresponding case studies. So as I said, we're not just active in on the commercial side of Postgres. We're not just putting Postgres into enterprises, which is, I mean, a lot of our work, but we have a significant number of team members who are fully engaged in the Postgres community and the ecosystem around Postgres. Obviously, Bruce here with me on this webinar, the founder or one of the founders of the Postgres developer group, and then Dave Page also working with us. And Dave Page is leading the development of pgadmin, one of the key tools around Postgres. Robert Haas, Amit Kapila, Devram Gunduz, for anybody who has used PostgreSQL Yum repo or RPMs with PostgreSQL, well, Devram is one of the key drivers behind that effort. And then many others who contribute code and commit patches, etc., in the project. So it's important that that everybody in this call understands that while we work obviously with large customers around the world, we also make significant investments into the Postgres development and into the Postgres ecosystem. So now let's start diving into PostgreSQL 12. I'll turn it over to Bruce. So Violet, if you can hand the presentation over to Bruce, please.
Great. Well, thank you, everybody. It's a pleasure to be here. I was in Southeast Asia in September and had a wonderful time. My wife was with me, and did a whole bunch of different cities and visited a lot of customers. I don't know if any of you customers that we visited are on the call, but it was a it was a great time. Spent I guess 10 days in Indonesia and Bali. We had a conference there, and then Jakarta, Kuala Lumpur, Singapore, and Hong Kong. So it was really nice. Violet was there. Got a chance to talk to a lot of people, and Mark was saying I might be gaining too much weight because we had so many of these big lunches. But you know, when you're a speaker, you don't get to eat, so you kind of get the table scraps at the end. Whatever nobody else ate, that's what you get to eat. So I'm not complaining. But anyway, it was a wonderful time. I hope to be back. Again, I have a long history of involvement with APAC, and enjoy going there at least once or twice a year to see what's going on. Always exciting things happening. And speaking of exciting, we have Postgres 12 features. These are the 8 really important features that I think of in Postgres 12. I'll give you a little backstory on this. As you know, we put out a major release every year, and every year, I kind of look in about March to see what we have. Like, okay, we've been doing development since July, so March is, I guess, 6-7 months from there, and you kind of look. And in Postgres 12, I got to say, I looked at what we had in March, early March, and I was like, I'm not super excited. We didn't have we had a lot of cleanup stuff, a lot of improvements, but not a lot of high profile items, at least in March. And I started to look around, I started to kind of poke people, and I said, there's a lot of problems and a lot of features that we've been working on for a couple of years, and they kind of got stuck. So for me, Postgres 12 is let's get some of the features that we've been struggling to implement for years done. And I really want to credit the team. I sort of sent an email out privately, and I said, hey, we really could use some people to finish up some stuff that's been lingering. Everyone, for those of you who've done development, there's always this like pile of features that kind of linger that you're not quite sure you got it right. And they're kind of hard problems, and you're waiting. The story had you're waiting for a unicorn to come over the hill and sort of save you. Well, I basically told everyone, listen, unicorn's not coming. Let's hunker down. Let's get this stuff done. We've been working on some of these things for several years, and that's what we have here. We have a powerful release. We have a strong release. And what's interesting is probably half of these are in the sort of category of I've wanted these for a couple of years and we haven't gotten them, and this is the release we get them. So I am excited about it. I'm going to go through that, but that's sort of the backstory in terms of Postgres 12. Again, we put out major release every year. There's about 170, 180 features in every release. That's pretty impressive to be able to put out that many good features that quickly. And some releases are stronger than others. This one, again, in March, wasn't looking too great. Now, by the end of April, it looked really good. So I'm just going to do the top 8 that I have. A lot of people have other lists and other highlights. I tried to sort of get the ones I was super excited about. So let's get started.
I think one thing to say here, Bruce, that you may play down that there's not a lot of super big, features, but there's a lot of stabilization. There's a lot of cleaning things up. There's a lot of areas to make sure that the features are completely usable around partitioning, around Beetree performance improvements, etc. That I think are really, really valuable, and I think the hardcore users of Postgres will really value that a lot of rough edges have been removed.
Yeah, there's definitely I feel like we spent a lot up until March. A lot of it was polishing out the rough edges from what we did before. But when I look here, number 3, MultiColumn Statistics, number 4, control of common table expressions, number 5, prepared plan control, and number 8, reindexing currently are all things that have been sort of on the back burner for years, that we got 80% of the way, and we kind of hit a roadblock, and we didn't know the exact best way to go forward, and they stalled. Some of these have been 3 years in the making, and they all kind of showed up at the end. So I'm actually very happy. It's just kind of weird that you had, from my perspective, a huge amount of polishing in the first 6 months. And then the last 2 months, I got all this stuff, all the sort of highlight stuff that I think was really, are real game changers in terms of Postgres usage. That's one of the great things about Postgres, and I have another talk that goes into a lot of detail. But one of the great things about Postgres is we go back and we polish stuff. We go back and we're always polishing. We're always completing features and making sure they're feature complete and they work completely well with other features and so forth. And I think you're going to see that a lot in this release. A lot of commercial vendors kind of take a feature 80% of the way and they just stop, and you basically have to live with that for 5 or 10 years until they may decide to revamp the whole thing again. Postgres is much more incremental, and I think you're going to see that in this release. Do you agree, Mark?
Oh yeah. I really like the work that has been done to complete the partitioning work, because I think partitioning is really important. There's more work to be done, but I think the current partitioning work and also the Beetree work has been really, really nice.
Yeah, the Beetree one's got a crazy story of its own. So let's get started. The big thing about partitioning in this release is the ability to use thousands of partitions efficiently. Okay. This is really an ongoing saga of partitioning syntax. I believe we added partitioning syntax in Postgres 10. Is that right, Mark? 10, 10 or 9.6?
Yeah, but that was not declarative syntax, right? That was inheritance based and not that efficient.
Right. So we've had partitioning from from back in the 90s or early 2000s, but up until the past couple of years, it was this what I want to call Frankenstein monster, where you took a head from one place and an arm from somewhere else and a leg. In this case, you were taking inheritance, you were taking check constraints, and you were taking triggers, and you were putting them all together to make inheritance. A couple problems with that. A, required a lot of maintenance on administrators. B, didn't scale well. And C, when you looked at the partition, you couldn't tell what it was. You had to kind of dig in to find it. So the user interface was poor, administrator interface was poor, scaling was poor. And again, we introduced the syntax in 9.6 or 10, but since then, we've been basically improving it pretty dramatically. So I think we ordered in 10, and then 11, we improved how you could add partitions and how the performance worked on them. And now in 12, we're now making it to perform even better. And again, ultimately, partitioning, we have an even greater goal here is to work with sharding and foreign data wrappers, which again is another talk, but we're not going to go there. Second thing is that now partition tables can be referenced as foreign keys. So you can now reference into a partitioned table as long as the reference column is part of the partition key. Okay, if the reference column is not part of the partition key, it'll fail. So again, this has been a request a lot of people have had. I have a partition table. I want to reference into it from another table. You can now do that as long as the key is part of the partition key. Improve copy performance in the partition tables. You can now express the bounds of partition tables with expressions. And we have some SQL functions to interpolate into partition tables. So again, I think we still have more to go. I know 13 is going to have even more. But again, this is the incremental development that we do. We're putting out a release every year. So we put the initial version in 10, and then 11 improves it more, 12 improves it more, 13 improves it more. But it's fully functional as you're going through those years, you're just getting better and better, faster and faster, more flexible, less maintenance, more automatic is basically the way that we typically develop features. Okay, number 2, Beetree Improvements. This is the biggest head scratcher of the year for me. I'm responsible for writing the release notes. In fact, I should have noticed right here. That's the URL. If you ever want to download the release notes, that's exactly where it is. So this is a huge head scratcher for me because I have to relate the release notes. And the way I relate the release notes is I go through the commit logs. So my family knows the week I write the release notes because it's like I'm just going to be like buried in this cave for probably 4 days, going through every commit, trying to figure out if that commit is warranted to appear in the release notes, rewriting it, researching what it does, whatever. This was the biggest head scratcher for me because it was made up of a whole bunch of commits, mostly by Alexander Korotkov and Peter Gagan, to improve the Beetree implementation in Postgres. Now, you would think, Beetree having been around for, decades, that there really wasn't a whole lot of improvement you could do, but we were kind of shocked that there actually was quite a bit of advance that we could make in the Beetree code. Peter Gagan really steered it. Alexander Korotkov was really kind of helping and kind of polished up a lot of the stuff. Between the two of them, I think they understood what was going on, but the overall community was kind of in the dark. We trusted these gentlemen. They're very capable. But they also talk about stuff that a lot of us can't really kind of get our heads around sometimes. So fortunately, Peter Gagan actually wrote a talk for the Ottawa Postgres PGCon. And he gave me a recording of that talk before he gave it with audio. And between his slides and his audio and the commit logs and the Git repository, I was able to figure out exactly what it was they did. Effectively, what they did was if you have a multi-column index, that is an index that has multiple columns, there was quite a bit of inefficiency of space use. So if you had a column with 3 columns or 4-column index, we were repeating a lot of these 4-column fields when we didn't need to. So one of the interesting things is that now multi-column indexes are actually smaller. 20% smaller, I think, is the number I heard, roughly. We improved the performance of indexes with many duplicates. This is another issue. If you've got an index with a lot of duplicates, the way Postgres was handling those was not ideal. It was a little odd the way that we handled free space, for example, and this is going to obviously be a huge improvement. One of the problems, though, is that you will only get a benefit with this feature if you create a new index. If you're using PG Upgrade, you will not get the benefits because the tables will effectively be the old format. So just be aware, if you're going to Postgres 12 and you're using PG Upgrade, you may want to reindex some of your tables to get these improvements. It was kind of surprising how well it worked. Numbers I've seen are maybe 40% smaller and faster. So again, really cool stuff. I thought Beetree was a done deal, but no. In fact, we have a woman in Russia who's working on even better handling of duplicates in Postgres, and she has a patch that's currently being discussed on the hackers list. So again, expect even more benefits. Beetree, which you thought was done, we're still working on. We did improve vacuum handling, particularly with removing many duplicates, really related to item 3, and Alexander Kotkov improved the locking handling of index lookups. So again, some cool stuff there. Some of the stuff you're going to need, if you're using PG Upgrade, you're going to need to reindex some of these indexes to get the benefit. But really cool stuff. And again, we have some stuff coming in Postgres 13 as well. But this was like really hard to figure out for me. So I was so excited when I was done, and everyone was happy. Number 3, this is, again, one of those that I've been just kind of wanting. This is Tomas Vondra from Prague. I don't know how many of you are optimizer folks or study the optimizer, but obviously Postgres optimizer is pretty important. And one of the areas, and probably the most common area, where we do not do a good job in optimization are multi-column lookups in tables, because the default statistics in Postgres only have statistics for single columns. So if you have a table with 10 columns, we'll create statistics for all 10 of those columns, no problem. But what if you do a lookup and you're looking at several columns at the same time? So in this case, we're doing city and state. Well, we have statistics on city, we have statistics on state, but we don't have default statistics on the combination of city-state. And that's what multi-column most common value statistics are. It gives us the ability to have most common value statistics for more than one column combination. So, for example, if you're looking for, El Paso, Texas, it's common. If you're looking for El Paso, Pennsylvania, there is none. So what it's trying to do is, if you've got queries that are using multiple columns and you're getting poor statistics or poor plans in those cases, multi-column statistics using this feature is really, really cool. I've been wanting this for a long time. I think it fixes probably 60 or 80% of optimizer complaints we have now that we have this. I've seen a reduction in the number of complaints, and I think this is really a really amazing feature, and something that I've been waiting for probably 4 years, because it's a very hard problem. There's a lot of mathematics behind it. How do you do it efficiently? And again, thanks to Thomas Vondra and Dean Rashad, who also had Rashid, who also did quite a good job of sort of handling and working with Tomas to get this feature in. So again, big feature for me. Number 4, this is really a good one. Many of you might have seen my common table expression presentation. Common table expressions are effectively a way of taking a query and making it its own separate table, and then referencing that in the main query. So it allows you to take, maybe you have a query that uses like 20 tables, you can actually break it up and join part of it in one section and part of it in another section, and then join them together at the bottom. This is also used for recursive queries, but in this case, it doesn't. The change here doesn't actually apply. But for people who are using common table expressions that weren't recursive, Postgres was actually creating what we call an optimization fence, which meant that if you converted a query to common table expression, you were not, the common table expression was always executed first, and then the lower query beneath it. And what Postgres 12 does is to no longer make it an optimization fence. It effectively, as you can see at the bottom, at the top query, you can see that there is a common table expression scan, because it used the select one here as an optimization fence. Select one being right here. This is the subquery. This is the common table expression right here. And in Postgres 12, you can see that effectively it has optimized this and put it in place of T, and we only have a result. Now that's obviously a silly query, but you get the idea. We now have sort of auto inlining of common table expressions. For those people who were using common table expressions and maybe saw poor performance, or maybe avoided common table expressions because they were worried about performance, this is the fix for you. This was done by Andrew Girth. You may have seen him as Rhodium Toad on the IRC channel. Incredibly gifted gentleman, and also somebody who's been with us for many, many years. Very excited to have this feature. And again, as you can see, this is a polish of a previous feature that was really way, way long overdue. So I was just really excited. I hate to see stuff getting like 98% there and like not get that extra 2%, because this is a big deal. And I think it's gonna really increase the use of common table expressions. Some people may not have even known that was an optimization barrier, but in fact, before Postgres 12, it was. Another one of those sort of sitting out there kind of problems, prepared plans. You may not know, but Postgres, the default behavior when using prepared plans is that we execute it 5 times. And we replan it all 5 times. Only on the 6th execution do we actually consider using the prepared plan. And for people who are running prepared plans hundreds of times in the same session, works just fine. If you expect the prepared plans to be used quicker than the 6th instance, you now have the ability to control that. So here's an example. We prepare a query. We pass in 1. We do it 1 time, 2 times, 3 times, 4 times, 5 times, and you can see in the 6th execution, we're now using the prepared plan, because you now see the $1 there appearing that you did not see in the previous example. So that is the default behavior. With Postgres 12, you now have a new server variable called plan cache mode. So if I set plan cache mode to be force generic plan, then effectively the system automatically uses a prepared plan on its first instance. In this case, you can notice that the $1 appears the first time I execute this new prepared plan. So again, a great polish for a feature that's been around for a long time. People may not have known the default behavior of Postgres is to run it 6 times. There's some historical reasons for that we do it that way, primarily because other databases that do not execute the query several times before considering a generic plan often get very bad query plans. Because if they've got constants that oscillate between common and rare in the first couple executions, the optimizer will typically just identify that it does not want to use a generic plan. But in the way Postgres works, you basically have to have constants in the first 5, 6 instances that are consistent in their selectivity. And only then will we consider a generic plan. This avoids a lot of the problems of prepared queries that we've heard from other databases. So it's been used for a long time. People have not complained about it. They've actually been very happy about it. But again, if you're the type of person who understands that your constants are already going to be consistent, you can force a generic plan right away. Number 6, this is the amount of code for this patch was like trivial. We implemented just-in-time compilation in Postgres 11. This was done by Andres Frude, and it was not enabled by default. So effectively in Postgres 6, the just-in-time compilation that we implemented in Postgres 11 as optional is now enabled by default. We also have him now working on some new features for just-in-time compilation for Postgres 13. So again, he has plans to improve this feature, hopefully in the next release of Postgres. Just-in-time compilation, for those who don't know, is the ability for the executor to instead of to run a LLVM binary version of the executor instead of using a state machine, which is the way we normally run the executor plans. The just-in-time compilation effectively takes the state machine and converts it to machine language, so that the executor is now running its state machine in assembly language instead of running in basically some state machine that we've executed in C. So again, very useful for data warehouse queries.
And
Number
Bruce,
7.
is this available?
Yes, please.
Bruce, is this available on all platforms, or just Linux, or is this generally available?
That's a great question. Currently, it's just Linux. Yeah.
Mm-hmm.
I don't think there is. I don't think there's a non-Linux. I don't remember. What I don't know is whether FreeBSD can do it. I don't think we have it working on Windows. Yeah.
No, on Windows,
Yeah.
I'm pretty sure it's not there.
Yeah.
Okay.
Yeah. But it might work on FreeBSD. You have to have LLVM. So if LLVM works, technically it could work. LLVM is basically a compiler tool set that people use when they're developing compilers like C compilers and stuff. And the cool part is that the way the compiler is designed, the assembly code generation part is separate. And the great part about that is you can use it in non-languages, like instead of using it for C, you're now using it for the state machine of the database. Well, I'm looking for really cool things coming out of this, particularly for data warehouse type stuff. But I think it's still in its infancy. It's sort of like partitioning. It's still. I talked to Andres actually privately last week, and he said, I think there's still an order of magnitude improvement in JIT that we haven't even gotten to yet. So again, this is more of us working into the large workload kind of cases. Number 7, many of you have probably used the checksum capability of Postgres. Up until Postgres 12, you effectively had to run initdb and to enable checksums. You couldn't add checksums to an existing server. Postgres 12 now, we have the ability. We have a new command called pg checksums, a new option. Actually, we had the command, but we now have an enable flag to it, and you can now enable checksums on an existing cluster. The one problem is it has to be offline while you're doing it, so it can't be doing it online. We are looking at online down the road, but right now it's an offline kind of capability to enable that. And the final one, reindexing currently. This is again one of those. When is the unicorn going to come over the hill to save us? We've been looking at reindexing currently. It's probably 8-10 years, maybe. I know it's ridiculous that hadn't been done. There are some complexities to reindexing currently. You would think it was easy because you can do it manually, right? You can create an index and then drop the old one and rename it, right? That's what we've been telling people for years. The reason it's hard is that it's a lock escalation case. You have a in the reindexing currently, which is a low lock level kind of operation. But to actually replace the index name, you have to get a higher lock. So what we were kind of stuck on here was how to run indexing currently with minimal locking, and then how do we get a higher level lock later on to actually rename the index in place. And effectively, we figured out how to do it. Cleanly. It still requires a high level lock, so you may It may run for a while until it gets the lock. But again, this is as good as we're going to do, right? We're not going to. There's no magic way of making this lockless because we got to put the index name in place to replace it. And to do that, we have to escalate our concurrent lock for a very short period of time to replace it, and that's exactly what this feature does. So those are the 8 things that I wanted to talk about. If you're interested in looking at these slides, the URL there on the left has probably 20, 30 presentations of mine. Many of them are recorded that you can watch. But if you're curious about these slides, or I referenced a bunch of other presentations in this talk as well, common table expressions and some stuff about the optimizer. There's a whole bunch of stuff there. People can spend hours or days there kind of listening and sort of soaking in Postgres knowledge. There is a blog there, probably 500, 600 blog entries, all categorized by topic if you're interested in that as well. So again, a wealth of information if you're so inclined. And that completes my big 8. I am very proud of this release, and I hope that you're going to be implementing it sometime soon.
Great, thanks. Okay, so Violet, back to you, and I think we're going to run a short survey now, right?
I'm wondering if she's muted.
Okay, so let me pull up the first survey question.
Violet, you'd have to share your screen or something.
Oh. Okay, the poll is launched now. Please take some time to answer the poll.
How are we doing on the poll?
Yeah, okay. I think, shall I stop now and read out the answers?
Yes, yes.
Sure. Okay. We have 86% who chose Postgres, 75% Oracle, 14% MongoDB, and 46% SQL Server.
Great, thank you, thank you. And those results will be part of the presentation that we're going to send out at the as a follow-up to the webinar. So I'm going to share my screen here again. Okay. So let's go forward. Bruce gave us a great overview of what is in Postgres 12, and I will talk about the features that are in Postgres Advanced Server 12. So that's EDB's version of Postgres. And let me first emphasize that EDB Postgres Advanced Server is a superset of PostgreSQL. So everything that Bruce talked about that is in PostgreSQL is available in EDB Postgres Advanced Server. EDB Postgres Advanced Server is a managed fork that we continuously synchronize with PostgreSQL. Usually we release about 6 to 8 weeks after PostgreSQL. So our target release date for EDB Postgres Advanced Server this year is November 25th. That's our target. At that point in time, we will also release all the other capabilities that go with Advanced Server, such as PEM, the Postgres Enterprise Manager, the EDB Failover Manager, the Backup and Recovery Tool, the Replication Server, etc., all synchronized to work with PostgreSQL 12 and EDB Postgres Advanced Server 12. So just for those of you that may not be familiar with Postgres Advanced Server, when would you pick EDB Postgres Advanced Server? If you like Postgres, obviously. Then you might make a choice for Postgres Advanced Server if you are interested in the native PLSQL compatibility, key Oracle packages like the DBMS family packages, the UTL packages, or if you're interested in things like Pragma autonomous transactions, data redaction, query hints, etc. Those are all things that we've added to Postgres to create EDB Postgres Advanced Server. We also added management tools such as a resource manager that allows you to manage CPU and I/O resource utilization by role, so that basically you can say a certain job running for a certain role uses too much CPU, maybe it's a batch job, and you can limit how much CPU that batch job can consume. That's a feature that you will know from Oracle and SQL Server. We've added it to Postgres Advanced Server because many DBAs are asking for it. We've also built on the wait states in PostgreSQL to create SQL session and system wait diagnostics to give you much better visibility into what is currently happening in the server and what happened, let's say, a half hour ago or an hour ago. So you have drill down capabilities that are similar to the ones that you may know from Oracle as the $V views. We've added an EDB loader for fast bulk loads, and we've added a number of security features. So Advanced Server, a superset of PostgreSQL. There are certain reasons when you might pick Advanced Server, and those are listed here. There are certain other features that we're adding every year to Advanced Server, and I'll just briefly go through those. What's new this year in Advanced Server is new compatibility features, so new system views that are like the Oracle system views that allow you to get a better understanding for what is happening and how the server has been configured. We've also added new statistical functions for median and list aggregation. Again, modeled exactly after what you will find in Oracle, and those are capabilities that today you don't have in standard Postgres. You would choose PostgreSQL if you want to use that. A lot of people make this choice because they come from Oracle and they want to use the same logic, the same stored procedures, the same packages that they've written in Oracle and want to run those in Postgres. And that's one of the key reasons why somebody would choose Postgres Advanced Server. Other capabilities are cast multiset, so a really nice way of converting the results of a subquery into a collection, or compound triggers, so that you can have a before and an after trigger all working on a shared common set of variables, so that you can create much more complex trigger expressions that combine the values that you had before and after the execution of a query. And then a very important thing that we've added in Advanced Server 12, which will most likely also be in PostgreSQL 13, that's the logical decoding on a standby server. That's something that you need if you want to have logical replication in a highly available environment where you want to be able to switch over the logical replication slot from the master to the replica in case of a failure. That is something that in standard Postgres today is not possible. We've implemented that initially for Advanced Server 12, and we hope to also make that available as part of PostgreSQL 13. And then a very interesting extension that we've done to partitioning, which is interval partitioning. For those of you that have worked with interval partitions, one of the challenges is that when you exceed the boundary of your current interval, let's say you partition by month and you transition into the next month, you now want to automatically create a new partition. That has been very problematic in standard Postgres, because when you have many processes trying to do that all at the same time, you create a large number of locks. And so we've created a mechanism to automatically extend the set of partitions if you start writing data into a new interval. walk you through a quick example here, where you have a table here of a sales table, and it is partitioned by month at this point. And I've created two partitions, one partition for January, a partition for February, and I've now started to insert data into my partitions, and that data is showing up in the different partitions. So now, when I start adding data into the next partition, then automatically the system, and you see that in the last row there, automatically the system will create me a new partition for the next month, and all of that is happening without incurring locks the way that would happen otherwise if you manually create a stored procedure, for example, that would automatically create a partition. That's been a problem that many of our customers, especially when they want to work with IoT data or other range partition data, have been complaining about significantly. So those were the features that we've added in Postgres Advanced Server 12. As I said, it's a superset of PostgreSQL. So all the things that Bruce talked about are available in Advanced Server 12. And we've added these features here again based on what customers have asked for. So Violet, I think we have another survey here.
Yes. Okay, so then this survey is, when do you plan to put Postgres 12 into production? Please select one of the following: immediately, 3 months, 6 months, or later than 6 months. Okay, Mark, maybe I think we are ready to share the answer.
Okay, yes, please, go ahead.
Yeah. Okay, close to half says 48% says that they will plan to do it in 6 months' time, and then 33% later than 6 months, and only 8% says they'll do immediately, and 13% 3 months.
Okay, that's a set of statistics that we hear about a whole lot. A lot of interest in moving things into production as soon as they're ready to be used at scale. And I think one thing we should talk about this here, Bruce, I believe, is about the process that Postgres uses to make sure that already a .0 version is really ready for use. Because I mean, I used to be a DBA of commercial systems, and there I know that we waited regularly at least a year before we put something into production. We would never put a .0 release in production, but in the Postgres world, I see a lot more willingness, and I think very responsible willingness to move new capabilities into production much earlier. And maybe Bruce, you can just expound on why that's the case in Postgres.
Yeah, when I was administrating in the 90s, I had the same experience. In fact, it was so bad with Informix that I stopped upgrading, because every time I upgraded, they'd fix two problems. They'd give me two different ones. I was like, I'm just going to stop, because I've worked around the problems I have, and I'm just not going to do it again.
Yeah, I didn't want to name Oracle, but that was exactly the situation. Yes.
Oh, really? Yeah. So the problem typically with closed source software is that the engineers have such little interaction with the user base that everything happens separate. In fact, I have some great presentations on my website. In fact, I have a new open source tab, and you can actually see a bunch of open source talks. But the basic problem there is that there's such poor interaction that all the design of the features happens in the company. Mostly all of the testing typically happens in the company. And you get this huge delay of all the testing happens in the company, and then only once they release it do the users see it. And then, of course, the users have a completely different way of testing and using it. And then you've got this huge, then all of a sudden the bugs come in, and they've got to go all the way through that whole maze of meetings to get to the fix. And then, so you can take months to even get the fix once you find it, right? But you find the bug. But because open source is so integrated with the user base, as we're designing the features, the users are telling us what they want, they don't want. As we're looking at the patches, everyone's saying what's wrong about it, including all my patches. When we apply the patches, people are testing right away. When we go into beta, we're shooting out betas like we can fix a bug today, and tomorrow somebody can download a new tarball and install it and test again. So the whole cycle of development is so rapid with open source. It's really the magic of how a project that has no money and no assets, like Postgres, can develop software as good as billion-dollar companies like Oracle and Microsoft. And
the Postgres has thousands of eyes looking at the code, right?
Yeah,
so,
it's
nothing
unbelievable.
Nothing
every time, every time as much time as I spend on a patch, when I eventually send it out, within 2 hours, somebody from some country I've maybe never been to will say, "Hey, there's this line right here is wrong," and I'm like, "Oh, I looked at it 50 times and I didn't see it," and then somebody else will find something else wrong with it. So before it even gets into the tree, the author's been pummeled because every mistake they've made has been sort of completely, they look obvious once somebody shows it to you, but when you're looking at it, it's not obvious, at least not to most people. But again, it's that continual focus on quality that gets that software so good. And again, part of that process, that's why all the open source stuff is really taking over in terms of, text editors, compilers, web servers, middleware, pretty much any infrastructure tool for enterprises is now almost all open source. And open source is growing in a whole bunch of other areas in terms of mobile and Internet of Things and so forth. So just that whole open source development model is just so superior that you don't get that .0 problem, because there is so much that goes on before that .0 drops. And if you don't believe me, just look at the release notes for 11.1 and 10.1 and 9.1, 9.6.1 and 9.5.1. And you'll see there's really not that much there. Yeah, there's a couple cleanups and stuff, but really almost all edge cases that we found that we hadn't thought of didn't come up in all our testing, and nobody saw it in the patch, and nobody saw it in design, and the author didn't see it. So you really don't have that huge cleanup, bring out the big broom and start to kind of shove stuff around in open source. Postgres is not unique there, but we have a very high responsibility for quality and a responsibility that we take data seriously, and that kind of comes across in what probably the biggest reason even for Postgres. People who have been using Postgres for years, the reason for that 6 months is typically not Postgres. The reason for that 6 months is that they've got to retest all their applications, and that takes time. So even for people who know that Postgres is going to put out a quality release at .0, it's typically going to be 4 or 5 months because they got to retest everything. There is an incompatibility section that you have to read. And make sure that what parts of that apply to you. You may not know right away, so you're going to have some kind of test suite to find out what they are. And that's really where the delay is. Most people tell me.
Thank you. So, Violet, let's dig into the questions.
Okay, thanks, Mark. It's interesting. I'm following your discussion and just wondering, based on what Bruce has just described about, giving the software a few months to run, would you think that, for a Postgres user moving into Postgres 12, would it be wiser for them to wait for a few more minor releases first before they upgrade to Postgres 12?
I think we are already. I think 12.1 is out, or Bruce, is it another week? I know it's.
I believe it's Thursday.
About to come. Yeah.
This Thursday.
Yeah. So I think we're already there at that level. And as Bruce was saying, I think this is a situation where you should look at it differently and take advantage of the new innovative features as fast as you can. Because after all, Oracle used to release something new every 4 years. Postgres does that every year. So if you want to take advantage of the new capabilities, well, you don't have all that much time. You can't wait for 3 dot releases and then say, okay, now I start to feel safe about it. If you do that, then you're not taking advantage of the new capabilities, and the performance capabilities and the new features are very significant. So I understand why one wouldn't do .0, but after .1, I would certainly consider it.
Yeah, a lot of people
Thanks.
complain that there's so many good features that they normally want to do major upgrades like every 4 years or 5 years, and like the first major release after whatever they installed, they kind of like, okay, there's a couple things in there I kind of wanted, but I can live without them. But by year 2, there is so much stuff that they want to use that they're kind of, they're like, slow down, don't be giving this all the time because it's just too much new stuff that we really want to use. And it's sort of the siren song. You're sitting working on something, you're like, well, if I had upgraded, this would all be, I'd be able to, this would be faster,
yes, exactly.
This would be easier. And that's actually the bigger complaint I get is just the features are just so good and they come out so quickly that people do have a shorter release cycle because they do want those new features because they're dramatic improvements every year.
Yes.
Okay, thanks, Mark and Bruce. I think we only have time for one last question. And with the popularity in containers, can someone run Postgres in containers?
Absolutely. In this series here, we've done webinars on how to run it on containers. On the EDB Postgres Rocks, there's a very simple, very short blog on how to do that. It's actually just 5 lines. Same thing with EDB Postgres Advanced Server. We did a webinar, I think, 2 weeks ago. I think next week we'll have a webinar on running Postgres with Kubernetes and having a highly available environment. So absolutely, I think the time for that has come. We are having the first customers who are running large-scale, mission-critical applications on containers. For most of our customers, it's still early. They're looking at it. A lot of deployment in development and QA, but we do have the first set of customers who are using, as we would say, containers in anger and using Postgres in containers for real. So definitely, yes, start looking at it. The best practices are emerging. There's still some questions around how to do certain aspects of tuning, but it's definitely a possibility now. Bruce, you want to add anything to that?
Yeah, that's great.
Okay, thank you, Mark and Bruce again. And this looks like we only have time for all these questions, but to all attendees, we will be posting all these questions on Postgres Rock Community, so your questions will be answered there. And we really want to thank you for joining us today. And we will be sharing this recording along with the slides with you as soon as possible. So once again, thank you for joining us, and we hope you have a good rest of the day. Thank you. Bye.
Bye.